Okay. So I think we're very privileged to have Jameson and Tatiana come and speak to us from the Future of Privacy Forum. That's 15 years old this year, I think.
Something like that.
Something like that, and has been driving the legislative agenda and thinking about data protection and privacy in the United States over that period, but now is also recognized globally as one of the most important kind of places of ideas and thought about the future of privacy. So let's welcome Tatiana, who is the senior counsel with the Future of Privacy Forum's legislation team in the US, and also heads, and this is what she's going to be speaking about today, the biometric work stream, and also Jameson, who is a senior policy analyst for immersive technologies and leads the Future of Privacy Forum's work on immersive technologies. So brilliant. They both have very, very impressive resumes that highlight their experience and their expertise in both of these areas. And which is why we're really lucky to have them. And they're going to come and talk to us about body-based data and immersive technologies. Over to you guys. Thank you.
Thank you so much, Chad, for the really, really wonderful introduction. I was going to do the introduction, but you did an even better job than I could do myself. So so thank you for that. As Chad mentioned, today we're going to talk about the use of biometric and body-based data in immersive technologies, what the privacy risks are, what existing and emerging laws say about this data. And then we're going to start touching on some of the best practices that organizations that are developing and deploying immersive technologies can start thinking about adopting to minimize these risks that we identify. So to start us off, yes, I'm going to turn it over to you, Tatiana.
Thanks, Jameson. So you'll notice during this presentation, we are actually talking about biometric and body-based data just a little bit differently because they do pose kind of different types of risks, though you could probably categorize biometric data as a form of body-based data. So let's kind of get into what that means. So most folks have probably had some kind of encounter with a biometric recognition system, such as facial recognition or fingerprint recognition. So biometric data is a specific type of body-based data where it's an automated recognition of your behavioral or biological characteristics. And this all comes back to this concept of identity. So like way back, even before technology was really getting developed, we were able to figure people out for who they were based on, what their voice sounded like, what their face looks like, etc. And as technology started to evolve, we started to figure out more sophisticated ways of identification or to scale up our capabilities of identification, whether that's in the law enforcement context or in the private sector context of allowing employees to clock in and clock out of work. So when we're thinking about the security context, we think of identity paradigms in kind of three different categories. So one being what you know. So for example, when you're logging into an account, it's your username and password or a passkey of some sort, what you have. So that could be an employee key card or an ID license, or it's who you are, which is where we get into the biometric recognition, biometric characterizations. So if you want to go to the next slide, Jameson. There is a little bit of a difference between verification and identification. So I'll just go over these really quickly. But again, going back to biometric systems, we're typically looking at things like your face, which is unique to you, your fingerprint, your irises, and other forms of modalities that are unique to each person. So with verification systems, we are checking somebody's identity and who they are, who they say they are, right? So if I am at TSA, and I give them my passport, I give them my ID, and they're matching it against me, either manually, meaning they are looking and comparing, or it's a facial matching system. This has a certain level of privacy risk because, again, these are specifically tied to somebody's identity and somebody's unique characteristics. And then there's identification, which is probably the highest risk type of data that really is out there. And that is because what you're doing is you're identifying an unknown individual to match that. So that is what you would think of in terms of like large scale surveillance. So for example, I don't know if any of y'all heard about the Madison Square Garden incident, but there, there was somebody walking into the stadium, the system was able to identify them and see that this was an attorney that was on a case that they were opposing, and they actually did not allow them into the stadium to watch the game. And so that is obviously a high form of oppression, and a lot of different reasons why identification poses a lot of different risks. So Jameson, if you want to go to the next slide, this will just show a little bit of how this system typically works. So using facial recognition, which is what most people are familiar with, what you do is you take a photo. They will take templates of what your face looks like and your unique vectors. So for example, like your nose to your ear, how far your eyes are apart, your mouth to your chin, etc. And of course, the more sophisticated the algorithm is, the more vectors that they're going to create. But regardless, everybody kind of has this unique template to them. You can see in the verification system, what they're doing is they're just comparing what they already have on file with what current photograph is being taken. In an identification system, you have a very large database, potentially legally obtained or scraped off of the internet, as opposed to a kind of opt-in model. So if we want to go to the next slide, the question here is, okay, so that's biometric data, always tied to our identity, always tied to unique characteristics. What is body-based data? So again, body-based data is kind of a general term to discuss data that is based upon or derived from your body. So apart from the context of identification or verification, we can think of things like detection and characterization technologies. So for example, instead of identifying who is in the photo, you might be saying, is there a human in this photo? Or where are the eyes? Or where are the hands, right? So for example, if you take your iPhone or your camera will often autofocus. If you can think of that little box that is being around somebody's face, that is kind of a detection function of what a face is. It's not identifying the person, but it is detecting where that face is. A step further beyond that is characterization. So what they'll do is you take the kind of same photo or the same kind of body data, and you are making some form of an inference about that, right? So is this person smiling or not? Are their eyes open? Are they happy? Are they sad? And there's a broad range of privacy considerations that I know Jameson is probably going to talk about, where if you're just identifying if somebody is smiling or not smiling, obviously that's going to have less of a privacy risk to it, but you can infer things such as like a health condition as well from similar forms of data. So Jameson, if you want to go to the next slide. Oh, this is all you. But the example that I was going to give here is, for example, gait data you can use to identify somebody. So gait is actually typically unique to a person. You can identify them that way. But you can also take that same data and be able to infer if somebody is pregnant or if somebody has Parkinson's or any other kind of muscular disease. So there is a little bit of a continuum of the privacy risks from biometric data over to detection and characterization. So Jameson, you can kind of talk about how it applies to Metaverse.
Yeah, so in XR and other immersive technologies, so these technologies require large amounts of data about users' locations, their immediate surroundings, their devices, their usage and gameplay, and then critically for this conversation, bodies and behaviors. So regarding body-based data in immersive tech, this could include face and head data. So that could be raw face images, facial geometry, your mouth movements, head and neck position and movement, otherwise known as 3 degrees of freedom, data about your eyes, so just raw eye images, your gaze or way you're looking, pupillometry, your pupil dilation, your blinks, the distance between your pupils, iris and retina measurements, and then periocular region, so the area around your eyes, which can reveal things about your age. From your hands and limbs, there are just raw hand images. There's hand position, gestures that you make, fingerprints, palm prints. As far as voices and sounds go, a raw recording of your voice, something called visemes, which is the sounds that your mouth makes, your voice inflections, which could, as Tatiana mentioned, could reveal things about health conditions, or someone's accent can reveal other personal information about them. in terms of body data, just raw body images, the position of your body, your gait, your body tracking, and then some emerging data types, which are not really as integrated into consumer-facing products, but maybe in the future include vital signs, and neural activity, which we're seeing more as neurotechnologies are starting to develop. So the data that's collected serves a number of functions that are core to the operation of these technologies. So a few examples include eye tracking. So this involves cameras that capture a user's eye movements, as well as other information such as blinks, pupil dilation, iris and retina. Tracking eye data, which is known as gaze, helps with optimizing graphics for more realistic experiences. It can be also used to prevent motion sickness, improve users' balance, and then also allow for more expressive avatars that better reflect the user's reactions in real time. And then additionally, in some cases, iris and retina data can be used to authenticate users, as Tatiana mentioned, allowing them to log into their devices. But also tracking where a user looks could also theoretically be used to learn about what content they look at, and for how long, which could be used to personalize information to them based on inferences of what they like, what they dislike, other characteristics about them based on the content that they're engaging with the most. So specifically, the devices will capture data about the user's pupils to determine what parts of the device's display that the user is looking at. So there's a technique called dynamic foveated rendering, which blurs a part of the screen that the user is not looking at, which, in addition to enabling better graphics in the parts of the screen where the user is actually looking, it also allows the device to lower the computational burdens and the likelihood of motion sickness, which is often caused by latency. So serves a lot of purposes that make these devices work and make them work better. Another function is body tracking, which involves cameras on devices that capture a user's hand, body, and head movements to create more of a sense of embodiment within a virtual space, and to allow users to interact with digital content via hand controls and gestures. So this helps create more realistic experiences. It also optimizes graphics, as the device can reflect the user's movements in the physical world more accurately in the digital world. And it's also possible to potentially derive behavioral insights from how users move, and infer their likes, dislikes, personal characteristics, demographics. In some cases, there have been a few studies this past year about using head and hand movement data in Beat Saber to actually be able to identify people. So it's not just inferring characteristics, it also could potentially be used to infer identity as well, given the right circumstances. And then another example is mapping and understanding a user's environment. So sensors that capture and analyze a user's immediate physical surroundings they serve a variety of purposes. In VR, they can create like a boundary zone around the user to make sure that they don't bump into something in the physical world. In augmented reality, it can help create place-based experiences. So, for example, Pokemon Go will anchor virtual characters in real places in the physical world, and users can interact with them only in those specific places. So moving on to the privacy considerations of all this. So privacy harms stem from particular types of data being used or handled in particular ways or shared with particular parties. So while body-based data often must be collected or processed or shared in order to actually enable the immersive experience, it can also give those with access to it significant insight into a user's into an individual's personal life and thoughts. So this includes not just an individual's unique ID, but potentially emotions, characteristics, behaviors, desires, and more. And because these technologies are evolving rapidly, it's not always possible to know exactly what insights or inferences any given data may be able to provide in the future as these analytics techniques improve. So as such, data that's generally considered low risk or not sensitive may at some point in the future be capable of revealing higher risk or more sensitive information. And so there are a number of factors that impact how much of a risk any given type or use of body-based data is. So some of these include identifiability, which is the ability to uniquely identify someone or link other data to a uniquely identified person, or the ability to infer somebody's identity. Another is sensitivity of data. So there are certain characteristics that are covered by law as sensitive data, and this includes race and ethnicity data, religious beliefs, other characteristics that I believe Tatiana will probably touch on later. And so the ability to infer sensitive information or sensitive data categories about people from non-sensitive information raises the risk that something could result in a privacy harm. Also, this information could be used for targeting and personalization, which isn't necessarily harmful. There are a lot of really positive uses of personalization based on sensitive data categories. But as you can imagine, it could also lead to discrimination if certain people are prevented from seeing advertisements for jobs or housing, for example. Another factor is the potential for inferences. And so this is similar to sensitivity. The ability to identify or infer information about an individual, including their internal state, could also raise the risk of harm. Data accuracy and bias, so how accurate and or representative or complete data is. If data is biased, it's probably going to lead to discriminatory usage. And then I kind of hinted at this before, but critical decisions. So whether a data practice is impacting an individual's access to something critical, such as housing, credit, insurance, the legal system, healthcare, education, career opportunities, things like that. So the example I gave before was if personalization was being used to exclude, people from certain communities from seeing an advertisement about access to education or a career, that would be a discriminatory use that results in harm. Another factor is the data sharing partner. So if an organization is sharing data with a third party, how likely a data sharing partner is to use that data or onwardly transfer that data in a way that is lawful and that is fair and that aligns with the organization's values and the user's expectations. Data retention, so the length of time data is kept, particularly in identifiable form. The longer the data is kept, just the higher risk that it will be used or that it could be used in a harmful way. And then finally, user expectations and understanding. So this refers to user familiarity with data types and uses. So how aware are users of data collection and use, what's being done with their data, the level of detailed understanding of the data practice. So if a user just knows, oh, they're using it for personalization, but they don't really know exactly what, that would be a low understanding. And then it's also important to note that for some immersive technologies like XR, when used in public places, they may inadvertently collect data about bystanders that are in the user's surrounding environment. These people will not be able to receive adequate notice if their data is collected. They certainly won't be able to provide consent, at least not the way that they're currently set up. And so while many companies are installing warning lights that let others know when recording is taking place, this likely would not rise to the level of legal notice. Some have compared this issue to the issue of people with phones in public, like phone cameras, and that norms just need to develop around what's appropriate in public. The question is whether, given the data aggregation and processing capabilities likely to be involved in and added to XR devices, if the comparison to a phone camera is an apt one. And so this is an evolving question that people are still thinking about. So that will move on to the legal and regulatory landscape. No, I think you're on mute, Tatiana.
I am on mute. That is really embarrassing. I feel like that still happens like once a day. So Jameson put out a lot of the good privacy considerations, and while the US does not have a federal comprehensive privacy law, we do have what is called a patchwork, meaning that we have a lot of different rules in different jurisdictions and across different data types. So some of the most applicable ones to what Jameson just discussed are the biometric data privacy laws, the comprehensive data privacy laws, and what I'm going to talk about is BIPA litigation. So under one of the biometric laws, there is a private right of action for individuals to sue companies for certain violations, which has shaped a lot of the law here. So I'll talk a little bit about each pretty quickly so we have enough time for questions. So first of all, biometric data privacy laws, these are focused specifically at biometric identifiers or biometric information. So again, going back to the first part of the presentation, this is focused at body-based data that is used for an identification purpose or is an identifier such as, again, your face template, iris, etc. Typically, these requirements are pretty bare bones as compared to some of the privacy considerations Jameson had talked about, and these were all passed in what I would say is the mid-2000s. So as GDPR was enacted, as CPRA and CCPA was enacted, these were much more before those came into being. But typically the requirements are about the same. Some form of notice and consent, some form of a limitation on selling and sharing data, typically a prohibition against selling the data, reasonable security measures, and then in Illinois, you have this publicly available policy that needs to discuss when biometric data is deleted and how long you're retaining it for. And in enforcement, in Texas and Washington, these are enforced by the Attorney General. And in Illinois, there is, again, what I said is the private right of action. So this allows individuals in their individual capacity to be able to bring lawsuits against companies for violations of this. So if they don't ask for consent, or if they don't tell them how they are deleting their data or when they're deleting their data, they're able to bring a lawsuit and recover damages, as well as an injunction or anything else that they seek. So James, you want to go to the next slide? We'll quickly talk about BIPA litigation. So as I mentioned, how a lot of people in the US think about biometric data privacy laws, what are the boundaries, what is the bare minimum that should be done, often centers around the Illinois Biometric Information Privacy Act. So this was passed back in 2008, when a lot more entities were starting to develop biometric systems. Again, categorizing these a little bit differently, body-based data is a little bit more of a newer development. Biometrics have been around for a very long time. So now they're starting to get more into banks starting to use fingerprinting and facial recognition. More private companies were starting to use facial recognition and fingerprint recognition. And all of this was occurring without any really regulations in place to be able to govern that or say how companies needed to be handling that data. So over time, folks have been able to bring these private lawsuits to ensure that companies are getting consent, to make sure they're having these retention and destruction schedules. And what's unique about BIPA, even among the PRA, is that there's a very easy way to be able to get to court. So typically in lawsuits, you have to do things like prove an injury, and there's a smaller statute of limitations. With BIPA, there's a 5-year statute of limitations, and you don't have to prove any kind of injury. You just have to prove that a company violated the law. So this has forced a lot of companies to have to settle with this. There's a lot of questions about whether that's good or bad, but nonetheless, it is certainly central in how biometrics are discussed in the US. And even Clearview AI, which is probably one of the most notable facial recognition companies, has been forced to, not only in Illinois, change their biometric data privacy practices, but nationwide because of how much they are negotiating these settlements. So on to the next slide. So as we discussed, biometric data is kind of just one category of data. In the US, there's 11 comprehensive data privacy laws. It could be up to 13 if we're getting a little bit vague on what we think of a comprehensive law, but these are really the main ones. So within these laws, biometric data is considered a sensitive category of personal information. So that means that they similarly have to have consumer consent for processing. They usually have to do a data protection assessment, meaning what are the risks and benefits of collecting this data. And in California, they have a right, consumers have a right to opt out of this processing. But sensitive data categories are broader. It isn't just biometric data. It's also health data, it's race data, it's all of these other categories. So if you're using, let's again go back to body-based data, you're not using it for a biometric purpose, but you are using it to infer a health condition. That would fall under the category of being a sensitive category and still be subject to these requirements. Next slide, please. So there is a little bit of a changing legal landscape and a big question that's happening right now, again, as body-based data is becoming more developed, more used by people, is when is body-based data considered biometric? So I laid it out as if it was very clear, but it is not often very clear, especially when laws are not always clear. So for example, what I have here is a screen grab of the Illinois Biometric Information Privacy Act, which covers both biometric information and biometric identifiers. You'll see in the biometric identifier section, it just lists certain types of data. So looking at face geometry, you can argue, and a lot of plaintiffs have, that when you just have a face scan, even if you're not using it to identify an individual, you still have to get consent, you still have to have a retention policy, a destruction policy, even if it's not identification. So for example, this has been applied to photo grouping, to any kind of virtual try-on, products for makeup or for hair or anything. And so there is a little bit of this gray area around, okay, you're capturing this body-based data and it's not specifically used for identification, but it could be used for identification. So should those be treated the same or different is very much in the air. Next slide, Jameson. I'm gonna go through these quick, but a couple other things that are just happening as trends is age assurance. It's another form of characterization technology, not again, automatically tied to identification, but it can be. This is often being used with kids, so obviously much higher privacy risks there. And yeah, Jameson, you can go to the next one. And then again, as we kind of talked about with health diagnostics, it's kind of the same question for body-based data. How will we regulate this data when it's being used for inferences? Same example that I gave before, right? Gait analysis can be used for identification, can also be used for health conditions. Some of these privacy regulations are trying to figure out where do these inferences fall in the law, and should all these forms of data and different purposes of data be treated the same? And next.
Cool. So just in the last few minutes, I'm going to quickly go through what organizations that are innovating in the space can do to both comply with the legal requirements that Tatiana laid out, as well as ensure that their privacy or that their practices prioritize privacy, safety, and equity. And so there are actually a number of general privacy principles that can be applied to the use of body-based and biometric data, specifically in the context of immersive technologies. So I was going to go through these principles and then explain how organizations can operationalize them when developing or deploying immersive technologies. I don't think I have time to give, I was going to give an example of like what this looks like for eye tracking, but I think I'll skip that because we probably don't have time. But so one of the main things that organizations can do is data minimization. So this involves limiting data processing to that which is necessary to fulfill specific objectives or provide specific features. So it's not just collecting every piece of data that you can and then trying to figure out what to do with it later. It's only collecting that which is needed for something that you have specified. And then closely related to that is purpose specification and limitation. So that is clearly and accurately communicating the purpose of any given data processing activity to the users prior to processing, and then not going beyond these stated purposes without letting users know, getting consent to do it further. Beyond that, transparency, so meaningful notice and consent. So providing adequate notice to users about data practices and obtaining meaningful consent. I think this is particularly important for companies in the immersive technology space, because a lot of the data types and the uses of data are going to be new to users, and they might not really understand why the data is being collected, how it's being used, what the potential risks are. So there's a big need. I mean, there's always a need to be transparent, but especially when users also need additional education about why they're even collecting it in the first place. It's particularly important. User controls. So users should be able to access personal data collected about them, correct it when inaccurate, and delete it when possible. And these controls should be provided to users in a clear, conspicuous, and contextual way, in a way that they normally interact with the application or the device. Another thing is local and on-device processing and storage. So processing and storing as much data on a user's device as possible, particularly for higher risk or more sensitive data, will lower the risk that it is misused. So for eye tracking, for example, eye tracking data can be processed and stored on a user's device rather than remotely. Third-party management. So the immersive technology ecosystem is made up of a web of organizations that, and a lot of technology ecosystems are this way actually as well, that disclose data to one another, each one providing different functions and different services and experiences. And so organizations need to ensure that the third parties that they partner with are not misusing data that they share with them, which can be done by conducting due diligence to ensure that the partners have privacy policies that are compatible with their own, and then developing developing policies that they must comply with through a contract to prevent misuse of that data. Another thing is data integrity. So organizations should ensure that their data is accurate, representative, it's complete, it's not biased, and then also it is protected from unauthorized access or other security threats. And then finally, privacy-enhancing technologies, or PETs, can allow organizations to put body-based data to use while minimizing the privacy risks. So particularly for higher risk data practices, organizations can implement things like encryption, differential privacy, federated learning, and synthetic data to allow this data to be collected or used, but also minimizing the risk that it will be used in a harmful way for the user or others. So that's all we got. As a final note, I did just want to mention that in early December, we will be releasing a risk framework for organizations that are developing or deploying immersive technologies that use body-based data as a way for them to understand their legal obligations, to understand the risks that their data practices might raise, and then how to think about implementing some of the best practices that I talked about to minimize these risks. So this has been kind of a little bit of a sneak peek of that. So be on the lookout for that.
Thank you, Jameson. Thank you, Tatiana. That was absolutely fantastic. I'm gonna ask for some questions, and while people are plucking up the courage, I might just invite you to come back and talk in the future about the risk framework. That would be really good. Yeah. We can talk about that offline, as they say. I could pick on someone because I thought, Eric, you raised an interesting point in the chat. Do you want to break cover and say something?
Well, can you guys hear me?
Yes.
I don't know, breaking cover. I just think that using blockchain for your personal privacy is more viable because you can own it on your own. By using biometrics, you can machine code in any part of your body if you want to. I'm going to make an example here. If you take your fingerprints, your eyes, your DNA, and let's say something else, blood type, and you use those four, and you machine code that. As you machine code that, you can hash graph this, and you can put that on the blockchain. And on the blockchain, you can have a private key that is yours, that you have the key to. And then any entity that you want to have access to your stuff, you can give them access to that via a public key, for instance. I do know that Norway, for instance, they are putting more and more of their medical records and everything on blockchain, and then also starting to give, privacy that way. And if your medical records, whatever records you have is put on blockchain, you can then give that, if you go to a doctor, for instance, and he is a specialist in psoriasis or whatever, you might not want to give him all the information about everything that's going on with you physically. You can actually give him access to what he needs to know, and you can timestamp it. So you will, by the end, he can look at the information, write down, and then do an assessment of what you need to do to get better. And then after that, it will disappear. So there are ways of doing this. I just think that using a government and saying that, oh, okay, well, this government entity is going to be working for you. I think in the end, the private companies are so interested in your private data because that's what they are selling, that the governments are going to eventually cave in, or in a sense of, it doesn't matter what government entity you are, but if they come in for national security reasons, say that, hey, we need access to this, they will have access to it.
Eric, excellent. Thank you. Tatiana, Jameson, do you have a thought about blockchain? Maybe slightly.
Not on blockchain, because I know very little about that. But it is a really interesting question because there is a conversation that I think is much farther ahead in other areas of the world beyond the US around digital identity based in the blockchain. And having biometrics being controlled that way. The US is nowhere near any kind of digital ID platform. A couple of states have tried to start moving towards it, but haven't gotten very far. So I know, at least in the US, you're completely right. I think that a lot of people are very skeptical about government use of biometrics for very valid reasons, especially when it comes to law enforcement and access to government benefits and immigration. Whereas a lot of private companies are using it much differently. And even those two different use cases present different forms of risk.
Okay, brilliant. We're at time, but because we're at the end of the meeting, we can just carry on going, because if there are more questions. Do we have any more questions? If we don't, I might take a kind of chair's privilege and ask you about clear, conspicuous, and concise in the metaverse. It's one of the things I worry about, is that, I mean, it's a strange thing to worry about, that everyone's just going to get another text-based, clear, conspicuous, and concise notice that they don't look at, and that actually the metaverse has lots of opportunities for helping people engage with information about their privacy and how the data is being used, that might make it easier and not just more complicated, and that maybe we could learn a little bit about the mistakes we made in Web 2.0. So I was just wondering, how do you think about language like that, that's so embedded in legal paradigms and being so recognized as textual? How do we start thinking about them in these different, more immersive, more graphical, more visual ways that can support data subjects in really getting a sense of what's going on with their data?
Yeah, you raise a really, really great point, Chad, that is super important, and a lot of people are thinking about and thinking through, is that if you have immersive technologies like VR that are so powerful because of embodiment and presence, and are, have all these different data modalities, shouldn't you be taking advantage of those new interfaces and those new design capabilities to inform users in a way that is more effective than just sending them a wall of privacy policy text, or just giving them a box to check? Because as we've seen, that doesn't do super well in traditional web and mobile in terms of getting users to actually understand what they're consenting to. And it definitely wouldn't work in 3D or immersive spaces. And so I think that people are starting to think about designing notice and consent mechanisms in more intuitive ways that fit with the interface of immersive technologies. So one example I'll give is a couple researchers are thinking about something called visceral notice. So visceral notice in other contexts is like, say you're driving on a road and your car starts to veer off a little bit, either into the median or off to the side. And there are rumble strips that kind of jolt you into realizing, oh, like I'm kind of going off track. That is an example of a visceral notice. It's contextual. It's more tactile. It's not just a box popping up on your car saying, "Oh, you're going off the road." It really it's visceral. People are thinking about, a couple of researchers are thinking about how to implement something like this in VR. And they're thinking specifically about eye tracking. So how do you design notice and consent mechanisms that actually take advantage of, that are visceral and take advantage of the more immersive nature of these technologies? And so some of the things that they're thinking about is on-screen icons that indicate when eye tracking is on, and where users are looking at, so users know that the feature is being used, they know how it works, they know what it's capturing, or in order to consent to allowing eye tracking to be turned on, you have to move your head to look at a few different icons on a screen to kind of mimic the actual process of what eye tracking is. It's looking, it's tracking your eyes to see what you're looking at. And so giving people this a more intuitive understanding of what the data practices are. There's a lot of work to be done on this, but it is something people are thinking about, and it is absolutely a huge opportunity for not just repeating the mistake of notice and consent in previous tech.
Jameson, that was really good. Are there anyone want to raise their hand? And while people are raising their hands, I think we might be having an audience that's leaving us as we're running over. But I just wanted to say it was really great you talked about visceral notice, and if I can have a second question, which is, how do we then stop visceral notice and those sorts of really innovative and interesting ideas about transparency falling into the same trap that you might say nutrition labels have, or standardized icons, or contextual indicators, where which are meant to have sort of kind of be applied now, but they don't really, they're either not applied or not applied in a way that makes sense. So there's often a big chasm between the great ideas about how we solve these problems and their ultimate implementation.
So another great question that I don't have an answer to. I think it's
maybe we should, as the PCI, maybe that's something we should be thinking about.
Yeah, and I mean, I think it's also a thing that it's always going to be evolving. Like it's never going to be you create visceral notice, you specific mechanisms for notice and consent that work now and they work forever. Like you're always going to have to adapting to how the technology evolves, to how user behavior evolves, and that's just a constant iterative process. There's never going to be a silver bullet. It just requires constant attention, I think.
And I think to a point that you raised earlier around like legalese, a lot of folks are very nervous about regulatory enforcement and litigation. So they try to follow the text of the law so closely, as opposed to like thinking big picture, like what is consent, what is meaningful consent. And more regulators and folks in the space are starting to think about contextual notice and consent and what that looks like. So again, coming back to you guys and what you all are doing, if you are at all talking to regulators or legislatures about this, bringing this up, because it's not top of mind for them, right? They're just not that immersed in immersive technology. So talking about these issues and how important it is to have context or allow for context in regulation, I think will be really important and valuable.
So Tatiana, just to follow up on that, because we'll stop in a second. But one of the things one's seeing in Europe and the States is regulators getting really into the design of things. So you look at the dark pattern regulation that's going on in all your states, and then also in regulation. So that sort of suggests that they are getting into thinking about the way stuff is presented to people and how they interact with it. But I suppose what we then have to now think about what's a metaverse dark pattern? How do we get them also to think more broadly than the kind of identikit approach that often exists with dark patterns in regulation? That there are patterns that one can identify, and rather than kind of thinking more broadly about maybe the choice architectures that sit behind those patterns.
Yeah. So yes, you're right on.
Yeah, that is a huge, I mean, there's a whole new Pandora's box of potential dark patterns, manipulative, deceptive design in immersive spaces that people are only starting to think about, and we will be thinking about. That's one of our big topics for next year.
Jameson, Tatiana, do you think that actually with these dark pattern laws, the law is ahead of the technology here? Because they do talk about deception, they talk about manipulation. These are broad concepts which could apply equally in the metaverse as they do anywhere else in terms of the design of an interface, which is where they focus.
Yeah, it's a really good question. It's interesting because it comes up in two different contexts, right? So the first I think that is important is FTC has been really cracking down on enforcement against dark patterns, and their authority is quite broad. They don't have to stick to specific law or specific legislation or specific text around what is a dark pattern, whereas regulators in other states that are bound by their privacy laws have to be a little bit more textually specific in what is being considered a dark pattern. So I actually think the FTC is really leading the way here in looking at what that looks like.
There seem to be a very distinct form of words that is appearing in all your state regulation describing dark patterns, which I suppose would apply to the metaverse.
Right. And part of the problem, I mean, it's helpful to have kind of a more broad mandate so that you're not really beholden to very specific things, but it also creates a lot of uncertainty for developers and designers. Like if they don't have a good sense of what is necessarily a dark pattern as the FTC would consider it, then they might, inadvertently or accidentally create a dark pattern, even if they weren't intending to. So they also want guidance on like what is a dark pattern so we can avoid it. Some obviously don't want to avoid it. Some want to exploit people, but I think generally a lot of people would just rather avoid it in the first place, but they don't have the guidance on how to do so in the context of immersive tech.
Yeah, absolutely. Right. Thank you so much for coming and talking to us. We've still got a lot of our audience with us, but I feel like holding you over for 15 minutes over is pushing our luck. We would love to have you back in the future and talk about your risk, your immersive technologies and risk. That would be fantastic.
Yeah,
and biometric data. It would be, so please come back. Thank you very much. It's been a brilliant session. And yeah, thank you.
Great. Thank you so much for having us.
Yeah, thank you.